Okay, these are some more notes on the cal limit chart, and this is example 5A, and we talked about the cal limit chart, and the fifth example we had was using the trig limits that we had derived using our calculator. And again, if you look at the cal limit chart, we've already gone over the first four examples, so this is number 5. And this is where we're going to use the limit sine of x over x equals 1 as x approaches 0. And this limit as x approaches 0 of 1 minus the cosine of x over x equals 0. So these are the two kind of trig limits that we use for limits. So we'll just call these trigged. Use trig. All right. And again, we have this first example, the sine of 5x over x. And if we substitute 5 times 0 is 0, the sine of 0 is 0, so I have 0 over 0. So again, I have to remember that this identity over here, or this, I won't say identity, this limit, the limit as x approaches 0 of the sine of x over x is 1. Now this is the sine of x over x, or the sine of something over that something. Now this is the problem. We've got the sine of 5x over x, but for these to match, as over here, we have to have 5x in the bottom. So how can we do that? Well, it's just all I need is a constant, so that's pretty easy to deal with. All I have to do is multiply the bottom by 5. Well, if I multiply the bottom by 5, I have to multiply the top by 5. 5 over 5 is 1, so I'm just multiplying by 1. Now I can move this 5 in front of the x, and we would rewrite it like this. So you can see how the bottom 5 goes in front of the x, and the top 5 just goes in front of the whole expression. Now I can use the constant rule. Remember, the limit of a constant times a function is the constant times the limit of the function. So I can bring that 5 out front. And now we have a nice, neat, tidy, the limit of, as x approaches 0, of the sine of something over that something. The sine of 5x over 5x, just like this. This will equal 1. So I've got 5 times 1, which is 5. Okay? So that's not too bad. Again, we do have to doctor it up so it matches. That 5x has to match that number at the bottom. Okay, here's another example. The limit as x approaches 0 of 1 minus the cosine of 2x over x. And again, if I substitute 2 times 0 is 0, the cosine of 0 is 1. 1 minus 1 is 0 over 0. So again, I have to do something to it, so I'm going to use this trig identity, or I'm sorry, this trig limit reality. In other words, the limit as x approaches 0 of 1 minus the cosine of x over x equals 0. Now again, this is the cosine of something over something, so like in the previous example, these have got to match. Here they match, here they don't. I need a 2 here. So again, I'll multiply the top and the bottom by 2, and I'll regroup it. I'll put this 2 in front of the x and this 2 out front. And again, I've got the limit of a constant times a function as the constant times the limit of the function. I could rewrite it like that. And now I've got this in the form that I want. 1 minus the cosine of something over that something. And as this is equal to 0, this is equal to 0. So I've got 2 times 0, which is 0. All right, and one more. And this is a tangent. So we haven't done anything with the tangent. This is example 5C. And again, if I substitute, the tangent of 0 is 0, so I've got 0 over 0 again. Now all my other function, all my other limits that I had derived were in terms of sine and cosine. So that's probably the route I want to go. So I know I can write the tangent in terms of the sine and cosine. That's real easy. So the tangent of x is equal to the sine of x over the cosine of x. So I just rewrite this as the sine of x over the cosine x all over x. And that's like x over 1. The reason why I wrote this was this is a complex fraction because I got a fraction in the numerator. So in order to clear this, it's real easy. We just multiply the top and the bottom by the least common denominator of all the denominators, which is in this case the cosine of x. Now these cosines cancel. So I end up with a limit as x approaches 0 of the sine of x on the top and x times the cosine of x on the bottom. And you can see here in black, this is my limit that I can use. I know that that's going to be 1. So I have to deal with this cosine of x. So what I'll do is I'll break this up into two parts. Sine of x over x times a cosine of x in the denominator, and I haven't understood 1 in the numerator. I can put that in. And if you want to check it out, all you have to do is multiply it out to check it out. Sine of x times 1 is the sine of x, and I've got x cosine of x. Now I'm going to use my product rule. The limit of a product is the product of the limits. So I can actually break this up into two limits, and I can write this as the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over the cosine of x. So that's that product rule. The limit of a product is the product of the limits. Okay? And what's this? Well, we know that that's going to be 1. And here I can just substitute because this is not going to be 0 over 0. If I put 0 in here, the cosine of 0 is not 0. It's 1. So when I substitute, I know that this limit is 1. And this is going to be substituting 1 over the cosine of 0. But what's the cosine of 0? 1. So I've got 1 times 1 over 1, or 1 times 1, which is 1. And there you have it. So I hope those help with your homework tonight.